I think one of the issues that's very important deals with coherence. It's a curriculum word we've used for years, and it's often used in a research type model or a curriculum writing model. But it's important that you have coherence in what you're doing. And that simply means that things are connected that you do. Oftentimes I hear people say, well, on Friday we do problem solving. And on Monday we do manipulatives, or we do stuff. And then on Tuesday they write in their worksheets or whatever they use. And it's not that kind of separation. If I think about it, let's say I can think of an example. If I use, if I make a game up or have a game that they have made up themselves, I do a lot of that kind of thing with numbers. Well, I can, in that game, make one of the things, first of all, is that you roll a dice with two numbers, and that they have to add those two numbers together first before they can move and play the game. So I'm working on those procedural basic facts, what people call basic facts, at the same time as they're working conceptually on this particular game that helps them develop place value. So I can put those things come together, but there's also a coherence in what we do, that it connects. It's very hard to talk about it in isolation like this, but see if I can give you an example that makes sense. Comparing quantities is certainly a big concept. It's a concept that's also procedural. So in pre-K, what I might do with young kids, I have blocks that are all different lengths, and they'll put one big block, put another block here, and have to see what's the difference. How could I make those the same? So in pre-K, what we did is I used these blocks, and we made bridges to go over the water, so that and they had to see it had to be the same height on both of them to put over. So it was all through manipulatives and the concept of making it tall enough. So I maybe had to add a little bit to this one to make it tall enough to put the block over. So it was a very conceptual understanding of comparing quantities. Then maybe I would have us line up and do the little comparing by shaking hands, one-to-one correspondence. And then maybe I'd use Unifix cubes to represent that. And then maybe we'd count those Unifix cubes and see how many more were in this group than this group. So it's a very conceptual understanding, but then we start to really work on number parts and part wholes. So it's a continuum that has to be built with conceptual, with procedural. So sometimes more conceptual than procedural, sometimes more procedural than conceptual. But it's got to be together. I don't see a lesson as today we're going to be conceptually understanding, and tomorrow we're going to do the procedures for fluency. And then the next, then there's practice with the fluency part. So it's got to be together. And I think to me right now, in fact, the book I'm working on now is how do I take these big concepts and show how they're developed over those grade levels and over those developmental areas is really probably the better word. I think we don't know that very well. We don't do that very well. And I don't know that it's our fault. I think we haven't been taught to think that way. I will tell you, I've seen it done incorrectly a lot. Oftentimes I'm called into a school or a group of people to work on this, and they'll say our teachers have just been using too much procedural stuff and too many worksheets and too much, and I'll say, yes, you're right. And the teachers keep doing that, then I'm supposed to work on the conceptual part, and boy, it just doesn't work. It doesn't work. You have to have concepts. You have to understand the concepts. Now, the problem is most of us as adults, many of us, I should say probably, maybe most, have learned math in a procedural way. I grew up knowing, boy, I could fill out any formula. I could memorize any formula. I was a math person. I just knew how to do formulas. I really didn't understand many of the concepts I was using until later when I tried to teach and realized, ooh, why does this work? Just because I had a big brain for memory did not mean I really understood math. And I'll have to tell you, I think I understood math the best when I've been teaching it for many years. So it's sometimes hard for us to think about things in terms of that. But I'll just tell you, when a kid has a concept for something, oh my goodness. I remember the freedom I had when I took my GREs, for graduate school. I remember thinking, I am so glad I know one formula. Because from that formula, because I understood all the relationships, I could derive any formula because I couldn't remember them. I can't remember all of them at that point. But boy, I just knew one formula. Then I could generate others because I knew those relationships. So when you discover that, it's kind of cool.